for 6-5, Properties of Logarithms. You have this Explore and Reason activity listed here. You may or may not be completing this based on further instructions for the class. So we have our essential question: how are the properties of logarithms used to simplify expressions and solve logarithmic equations? So that brings us to our concept, which has some of the different properties of logarithms that we're going to be using. You can see here the product property. This is when you are multiplying two logarithms together, or I'm sorry, not multiplying two logarithms, but if the argument of a logarithm is some type of product, you can actually separate that out into adding the logarithm of each part of that product. So you can see here we have log base b of mn. That's the same thing as log base b of m plus log base b of n. So you can split apart products into two separate logarithms, and along the same lines, if you have two things that are being added that have the same base for their logarithms, you can rewrite that as a single logarithm. Quotient property is very similar, except for if you have a quotient within a logarithm, then you can subtract the logarithm of each part of that quotient. It's always top first and then minus the bottom. And then the power property, which is related to the product property, if you have the logarithm of some argument that has an exponent, you can put that exponent out in front. That's going to be the power property. So over here on the right-hand side, I actually did one using the power property. So for example, log of some base of 4. Well, 4 can be rewritten as 2 squared. So by the power property, I can put that 2 out in front. So that's 2 times log of some base of 2. There's 2 additional properties that I did want to put up here because they do come up once in a while. If you take the logarithm of 1, it doesn't matter what your base is, that's always equal to 0. And that's because anything to the 0 power is equal to 1. And then similarly, if you are taking the log of something and your base and your argument are the same, that is equal to 1. So log base 2 of 2, log base 3 of 3, log base e of e, so that's natural log of e, those are all equal to 1. So if your base and your argument are the exact same thing, that is going to equal 1. We're skipping example 1. Example 1 goes through some of the methods for how you can prove these properties. You can look in your textbook if you're interested in seeing those. So that brings us to example 2. How can you use the properties of logarithms to expand each expression? So we have a single logarithm, and I am going to expand it as far as it can go. So log base 5 of a to the 2nd times b to the 7th. Well, this is a product, so I can rewrite this, and you'll have to excuse my board here. It's been giving me fits today. This is a product, so I'm going to add these 2 logarithms together. So log base 5 of a squared, and then log base 5 of b to the 7th power. Those both have exponents, so we can put those down in front. So this is going to be 2 log base 5 of a plus 7 log base 5 of b. And that would be your final answer for that question. Part B is a natural log of a quotient, so we would use the quotient rule. I am subtracting, so I have the natural log of 25 minus the natural log of 3. 25 can be rewritten, so this actually isn't as expanded as it could be. So this is the natural log of 5 squared minus the natural log of 3. With the 5 squared, I can put the 2 out in front using that exponent property. So I have 2 natural log 5 minus natural log 3. And that would be your final answer for that question. So if we're doing an example where we are expanding logarithms, we are also going to do an example where we are combining our logarithms. So for parts A and B, we are going to write these with a single logarithm. If you have a number out in front, you have to make that your exponent first before you can do any type of combining. So this 4 has to become the exponent for m, the 3 the exponent for the n, and then my last logarithm is not going to have an exponent. So log base 4 of m to the 4th plus log base 4 of n to the 3rd, and then minus log base 4 of p. By the way, I don't know that I've explicitly stated it, but you can only use the three properties, the product, the quotient, well, really the first two properties, the product and the quotient rule, if you have logarithms that have the same base. If they have different bases, then most of these properties don't apply, and you can't use them to combine. So log base 4 of n to the fourth plus log base 4 of n to the third. These logarithms are being added together, so this is a product rule. So this is going to be log base 4 of the product n to the fourth times n to the third. And then I have my log base 4 of p. Now I have a logarithm minus something, so this is now going to be the quotient rule. And you could probably have combined them all together using one step instead of two different steps like I did. And I'm going to rewrite this up here because I'm out of space going down. So this is going to be the log base 4 of n to the fourth, n to the third, and then p is going to be in the bottom of that quotient. And that will be your final answer there. Oh my goodness. Let's try that again. This is just all over the place today. Okay, so part B, I have 3 natural log 2 minus 2 natural log 5. Again, I do have to rewrite that with my exponents first. So using the that third property with the exponents. This one I can actually state what 2 to the third is. So this is going to be natural log 8 minus natural log of 25. I am subtracting these logarithms. They're both natural logs, so they are going to have the same base. I can write this now as a quotient. So this would be the natural log of 8 over 25. And there's nothing else I can do to simplify that. That's just going to be your correct answer there. Obviously, if your fraction reduced, you would reduce your fraction. However, these have no common factors, so there's nothing we can do to reduce that. Example 4, we're not actually going to go through and work out. This one, it is in your textbook if you want to look at it and see how you would go about solving this, but it does have an equation with the pH, how to figure out the pH based on the concentration of hydrogen in some type of substance here. So you are doing a logarithm of a quotient here of 1 over h plus. Well, because that's a logarithm rule, that's going to be the quotient rule. That's log 1 minus log of your h plus. And log 1 is 0, so this is 0 minus log of h plus. So it's really just negative log h plus because the 0 doesn't really matter. And for this one, it says, what's the concentration in acid rain? So you're going to be using 4.5 as your pH. So you're actually going to be working backwards. You're probably going to have to change that into an exponential to solve. And again, that's in your textbook. So example 5 now, we are going to do an introduction to the change base formula. And this is kind of an exploration that tells us where the change base formula comes from. So if you recall, just one of our rules of algebra is we are always allowed to multiply by a factor of 1. So let's say with this particular problem, I can multiply by log 2 over log 2. Log 2 over log 2 is 1. So I'm really multiplying by a factor of 1 in this problem. Well, now, the way this is written, log base 2 of 3, the thing written in black that I have out in front, I can write that as the exponent of the 2 with the log 2, and that's using the exponent property. So this is equal to log of 2 to the log 2 of 3, log base 2 of 3 power, and then that's all over log 2. Well, 2, and I'm going to, let's do this as an aside here. 2 to the log 2 of 3, if I were to rewrite that, let's say I'm going to set that equal to some x. So this is the same thing as log base 2 of x is equal to log base 2 of 3, that means that x has to be equal to 3. So this whole thing is equal to 3 because we get 3 for the x. So if I come back over here, this piece is the same thing as 3. So this is log of 3 over log of 2, which means that log base 2 of 3 is the same thing as the common log of 3 divided by the common log of 2. And that's what the change base formula goes over. You can rewrite any logarithm. You see here we have log base b of m. That can be rewritten as log of some new base of a of m divided by log of that same base of b. So you're going to pick some new base. In the previous example, we used the common log, so that's base 10. You could change it to a base e problem. You could change it to a base 20 if you wanted. Typically with these, you are going to change them to base 10 because base 10 is one of the buttons you have in your calculator, and you don't have to worry about trying to come up with some different way of solving it because you have that log. Base E is also a common one where you could change them to be natural log. So I know this is log base A of m over log base A of b. That would be the same thing. If I wanted to write this using a natural log, it would be the natural log, and you'll find I make that mistake a lot. I always want to combine the L and the N into one thing. The natural log of m divided by the natural log of b. It's the same thing. My base there is just e. So we have this example 6. It says, what is the solution of the equation? Express the solution as a logarithm and then evaluate. So the first thing that I want to do here is rewrite this as a logarithm. So my base here is 2. So this is going to be a log base 2. My argument is going to be 7, and that's equal to x. Well, using this change base formula, this is the same thing as the common log of 7 divided by the common log of 2. So you see your argument goes on the top, and then your base is going to be on the bottom. And then when we put that in the calculator, so that's half of our answer. It says express it as a logarithm and then evaluate. So there's my expression as a logarithm. We would type that in the calculator, and you were going to get 2.807 because it says nearest thousandth, so that's 3 decimal places. So that's your approximate answer. So you really need to pay attention to whether whatever you're looking at is asking for an exact answer or an approximate answer. In your textbook on page 330, there is a concept summary, so you can check that out and go through and make sure that you have all the parts of the properties of logarithms covered. We are going to be looking at 6-6 eventually, and that furthers our solving of logarithmic equations, really building on what we did in that last example by using those common log bases to solve equations that can't otherwise be solved. So go back through, rewatch this video. Make sure you really do pay attention to those properties of logarithms because they're extremely important and they make logarithm problems a lot simpler than what they are originally. And as always, reach out to me if you have any questions.